Hi, I'm Guang, 15 years old. In this lesson, we are taking a look at techniques and applications of definite integration. Now, for this example, we're going to have this lesson. It is a type of double integration. So in this double integration, we have a boundary, D, and we have the integrand x squared y squared, and we're integrating with respect to x and y. So this boundary, D, it's bounded by xy is equal to 1, also known as y is equal to 1 over x, xy is equal to 2, or y is equal to 2 over x, y is equal to x, and y is equal to 4x in the first quadrant. Right, so firstly, we could try to visualize what we see over here, okay? So, in the first quadrant, we're just going to draw out what we have in the first quadrant, right? So, x is equal to y, or y is equal to x. Then y is equal to 4x. So this is y is equal to x. And you have y is equal to 4x. Now, xy is equal to 1. We just draw the y is equal to 1 over x graph. And xy is equal to 2, which you can just draw it as the y is equal to 2 over x graph. Okay, so this area here is what we have. Alright, now what's so special about this area here? If we were to have double integration, let's say with respect to y first or something. Now, if you realize, we do have a few different functions that covers this entire area. Now, these few functions, we do have to separate them into different integrals, okay? That means we have to determine what exactly are the different boundaries. So, we could have one first place. So this can be one piece of it, alright? And then you can have here as another part of it. Okay, so here we have two of the pieces already, while the last is just the rest of it, basically, okay? So we do have these three different pieces that we have to separate this graph into. Now, to determine what are the coordinates. Now, this coordinate over here is when y is equal to 1 intersects with y is equal to 4x, which means you have to take 1 over x, let it be equal to 4x. So when 1 over x is equal to 4x, that means y is equal to 4x squared. So for that point, we are going to have x is half, since 4x squared is equal to 1. So then half, you can multiply it by 4, which gives it 2. Which from here, you could also make this like, let's say, point A, point B, point C, and point D. So A is half 2, okay? Now, how about let's take a look at B. Now, B is where you have y is equal to 4x equal to y is equal to 2 over x. That means 4x is equal to 2 over x, which is 2x squared is equal to 1. So 2x squared is equal to 1, x squared is equal to 1 over 2, and you have square root both of that to get square root 2 over 2. So square root 2 over 2, and of course for your y coordinate it will be 2 square root 2. Okay, so that will be your coordinate for point B. Now, we take a look at point C. So, point C, y is equal to x and y is equal to 2 over x. X is equal to 2 over x. X squared is equal to 2. So, x is equal to square root 2. So, square root 2, well, y is equal to x, so square root 2. Now we have point D. Point D is 1 over x is equal to x, which is just 1. 1, 1. Okay, so these are 4 of the more important points that we have to know. Of course, you can try to know what this point is, what that point is, but it wouldn't really matter if you think about it, since you just need the x coordinate, which you have over here already. Of course, this could just be one of the various ways to solve this question, since in this case we're going by y-axis first. You can also go by x-axis first, why not? So in this method, we would just be taking a look at y-axis first. Alright, so for this part over here, now separating them into 3 different regions to integrate. So the first region will be this red area, okay? So this red area, from its, when you integrate in the y direction, you go from y is equal to 1 over x to y is equal to 4x. So that means the boundary here would be y is equal to 1 over x to y is equal to 4x. For your x coordinate, you start from the x coordinate of point A to the x coordinate of point B, which is half to square root 2 over 2. Alright, so this is your red area. Next, we will take a look at the green area. So the green area, you have y is equal to 1 over x to y is equal to 2 over x. And your range for x would be from x coordinate of point B to x coordinate of point D, which is square root 2 over 2 to 1. Okay, so that is your green area. And of course, lastly, you have your black area. Alright, so you have y is equal to x to y is equal to 2 over x. And you have x coordinate of point D to x coordinate of point C, which is 1 to square root 2. Right, so these would be the 3 integrals that you would need to solve. Right, now let's take a look at each of them, since you have to integrate with respect to y first. So, y first. Each of them is just y squared, and when you integrate with respect to y, you would take x as just a constant, which means x squared is going to remain the same throughout each of them. Well, the only change is 1 over 3 y cubed, y is equal to 1 over x to y is equal to 4x, and then dx. So x squared, y cubed, y in this case is from 1 over x to y is equal to 2 over x, then dx. Or the next, you have to integrate from 1 to square root 2 to get x squared y cubed, y is equal to x to y is equal to 2 over x dx. And next, we would substitute them in. So when you substitute them in, you would get 6 different terms. Now the first one, 4 cubed is 64. So 64x to the power of 5 minus 1 over x dx. And for your second part, you're going to have 2 cubed, which is 8x to the power of, no, not to the power of 5, since there's a over x, so this is 8 over x minus 1 over x. So you can just combine this to become 7 over x. Now, in this part, you're going to have 8 over x minus x to the power of 5. Okay, so these are the few different terms you will see. Now we can integrate each of them. So, for x to the power of 5, you're just going to have to multiply it by, or you could just not write it, and just directly put 1 over 6, alright? So, this is what happens when you have to integrate x to the power of 5. Half to square root 2 over 2. And next, for your minus 1 over x, you have to minus 1 over 3 ln x, where x is from half to square root 2 over 2. Now this part, you just have 7 over x, so plus 7 over 3 ln x from square root 2 over 2 to 1. Here you just have 8 over 3 ln x from 1 to square root 2. And lastly, you have to minus 1 over 3 times 6 x to the power of 6 from 1 to square root 2. Is this right? So these will be the different terms you're going to have to solve. Now take a look at it first. Of course, we could simplify this a little bit, which will give you 32 over 9 x. So 1 over square root 2 to the power of 6, which is 1 over 8. Then you have to minus 1 over 2 to the power of 6, which is 64. And then minus 1 over 3 ln square root 2 over 2 plus 1 over 3 ln half, then plus 7 over 3 ln 1 minus 7 over 3 ln square root 2 over 2 plus 8 over 3 ln square root 2 minus 8 over 3 ln 1 minus 1 over 18. So square root 2 to the power of 6, that will be 8 minus 1. Okay, so this is what you will need to solve. Alright, now let's see what do we get from this portion over here. So from your first pair of fractions, this will just be 8 over 64 minus 1 over 64, which is 7 over 64, and you get 7 over 18. And from this part, since you have ln 1 over square root 2 with this part, which means you can have negative 8 over 3. So ln 1 over square root 2, using the property of logarithm, you can just change this into ln square root 2. And of course, for this part, you would also be able to change it into ln 2. So you have this, ln 1 becomes 0, ln 1 becomes 0, and you will just have plus 8 over 3 ln square root 2. And of course, behind here you have minus 7 over 18. Now this first term and the last term, they will cancel out. Well, we can take a look at what happens inside here. Since you have 8 over or 4 over 3 ln 2 plus 4 over 3 ln 2, or you can just 8 over 3 ln 2 minus 1 over 3 ln 2, which is 7 over 3 ln 2. Alright, so this will be the final answer that you have. Right, now let's take a look at how do we get here. Now firstly, when we had this question, we took a look at what exactly does it look like, and this is what you have. Right. Since we will be integrating with respect to y first, we can split it into 3 parts like this. But if you want to integrate it into by x first, why not? You can just split it in a different way, okay? But in this method, this is how we will be separating it. Right, now these 3 different parts, you have to find the coordinates of all the intersections in order to know how would you exactly split it. Now, after you find all of those, then you will be able to get these 3 different integrations. With these 3 integrations, you would go through a chain of integrations. Then at last, using a bit of properties of logarithm to get the final answer 7 over 3 ln 2. Alright, so I hope for this lesson you understand everything so far. I'll be ending it here, and thank you for your watching.